Next, we can use SPSS to run regression. Here presents the data view for SPSS. So we entered the data for X, we entered the data for Y. To run regression, we go to Analyze, click on Regression, click on Linear, then move the Y variable to dependent box, then move the X variable to the block of 1, this box. Then click on OK. It gives you 4 tables. These 2 are most important. The first table is actually the last table, is a coefficients table. It gives you the slope and the intercept based on this data set. The column is labeled unstandardized coefficients. B is the unstandardized regression coefficient weight. So the number next to X is the B weight. So B weight is 3. Then the number next to constant is the intercept. Therefore, the regression equation is Y equals to 3 multiplied X minus 8. Here is the beta. This is the standardized coefficient for the X variable. In this regression equation, we only have one predictor, which is X. We have one outcome variable, which is Y. So we have B weight for X and we have beta for X. In advanced stats class, you will learn multiple regression. For multiple regression, you will have more than one predictors, where you have X1, X2. So here we have just one predictor, 1X. Then this is the t-test for the regression coefficient. It is 2.739. Then the p-value is 0.071, so it is not significant. The first table gives you the R. This is the correlation coefficient between X and Y. You'll notice that these 2 values are the same. R is 0.845 and beta is also 0.845. Therefore, the correlation coefficient equals to the standardized beta weight. Finally, I want to remind you that what is the similarities and the difference of correlation and regression. They both, in fact, describe a relationship between variable X and variable Y. For correlation, it only describes how one variable change along with another variable. So X change, Y change, or Y change, X change. It does not matter which variable goes on the X-axis or the Y-axis. Here is the relationship between parents' IQ and the children's IQ. The correlation is 0.50. You can put the parents' IQ on the X-axis, or you can put the parents' IQ on the Y-axis. It does not matter. It does just mean they change together. That's correlation. On the other hand, the purpose of regression is different. For regression, we want to predict Y from X. We want to predict Y from X. So X is also called a predictor or independent variable. It must be on X-axis. Predictor must be on X-axis. And Y is called the dependent variable or the criteria. It must go on the Y-axis. With this regression line or regression equation, we want to predict children's IQ with a parent IQ. We want to know the Y hat. That's the purpose of the regression. To summarize, today we learned what the best fitting line is, what the rationale of choosing this best fitting line. Second, we learned how to compute the regression equation, how to compute the intercept and the scope. Third, we learned how to use the regression equation to predict a Y. Then we focused a lot of attention on the relationships among R, B, and beta. What is the relationship between R and B? What is beta? Why is beta equal to R? Finally, we explained the similarities and differences between regression and correlation. That's everything for the lecture. So you should finish the whole in-class exercise. I will collect this in-class exercise next Tuesday. Then you will need to work on the lab worksheets as well as the homework assignments. The TAs will collect lab worksheets and homework assignments during the lab section next week. Okay, thank you. Have a good week. Bye.